All right, this is going to be rationalizing denominators part 2. And what's going to be different on this one is that we're going to have at least 2, sometimes 3 things in the denominator. So we're going to start with something like this.
So wait, what are we planning on getting? Chocolate?
Yeah, like the chocolate basket.
Yeah, oh yeah, thank you for
Yeah.
So the thing here is that each of these has a fraction exponent. But I need to take each of them individually. So I need to look at the x and say, what am I going to add to 1/3 to get to 3/3? And it's going to be 2/3. So I'm going to multiply by x to the 2/3 on the top and the bottom. Then I look at the y. What do I need to add to 2/3 to get to 3/3? That's 1/3. So I'm going to multiply by y to the 1/3 on the top and the bottom. And then I look at the z. What do I need to add to 1/3 to get to 3/3? And that's going to be 2/3. So I'm going to put z to the 2/3 on the top and the bottom. So this 3 is still there. 3x to the 2/3, y to the 1/3, z to the 2/3 over, this is now x to the 3/3 or x to the 1, y to the 3/3 or y to the 1, z to the 3/3 or z to the 1. Now it is going to ask me to write them as rational expression, as a radical as well. So the 3 is on the outside because he doesn't have an exponent or a fraction exponent. All of the exponents have a denominator of 3, so that's going to be my index. I'm going to have x squared on the inside because of this. I'm going to have y to the 1 on the inside because of this. And I'm going to have z squared on the inside because of this. Denominator stays the same. So that's writing it as a radical. So that's what we're going to do here. So do another example here. X to the 2/5, y to the 3/5, z to the 1/5. So I'm going to look at this and say, what do I need to add to 2/5 to get to 5/5? And that's going to be 3/5. Whatever I multiply on the denominator, I also multiply on the numerator. I'm going to look at this. What do I need to add to 3/5 to get to 5/5, which is going to be 2/5. And whatever I multiply on the denominator, I also multiply on the numerator. What do I add to 1/5 to get there, which is going to be 4/5. And whatever I multiply on the denominator, I also do on the numerator. So this is going to give me 4x to the 3/5, y to the 2/5, z to the 4/5 over x, y, and z. Those are all to the power of 1 now. Writing it as a radical, the 4 is still on the outside. These all have a denominator of 5, so an index of 5. I'm going to have x cubed, y squared, z to the 4 over x, y, z. The denominator doesn't change. And that's it. So, problems that you're going to turn in. I want you to do these problems right here. So I want you to do number 1, 3 over x to the 1/8, y to the 3/8, z to the 5/8. 2, write your answer to number 1. With a radical. And that's it.